In this video, we'll write the balanced net ionic equation for KNO3 plus Na2SO4. We have potassium nitrate and then sodium sulfate. This is a double displacement reaction. So the first thing we need to do, we need to balance the molecular equation. So I can see I have one potassium here and two here. Let's put a 2 in front of the KNO3. The potassiums are balanced, but now I have two nitrates and only one here. We put a 2 in front of the sodium nitrate. That's done. We have two sodiums. Those are good. And we have a sulfate on each side. So that's the balanced molecular equation. Now we're going to write the state for each substance. That looks like this. So nitrates are very soluble. So we know these will be soluble. Compounds with sodium, they're very soluble as well. Compounds with potassium, very soluble. And the sulfates, very soluble. Everything here is soluble. And what that means is that we don't have any reaction taking place. There's no reaction because everything's soluble. Let's take a look at the complete ionic equation here just to see what that means. So the top reactants, the bottom are the products. So you can imagine we mix the KNO3 and the Na2SO4 together. These are the ions that we're going to get. When we do the double displacement reaction, the K2SO4 and the NaNO3, since these are both aqueous, they're soluble, these are the ions that we'll have in the test tube when we're done. But these are the same ions, so nothing has changed. There's no reaction. If we crossed out the ions that are the same, we call these spectator ions. In the reactants, two potassiums. They're gone. Two nitrates. Two nitrates. A sulfate ion. And finally, in the reactants, we have the two sodiums. In the products, we have two sodiums. Everything here in this equation is a spectator ion. So there's no reaction when KNO3 and Na2SO4 are mixed together. This is Dr. B with the balanced net ionic equation for KNO3 plus Na2SO4, except there's no reaction. Thanks for watching.